Hey everybody, it's Mr. Carr again. Today we're looking at 9-2 day one. Today's goal is going to be graphing more of our polar equations and also be able to identify and graph some classical curves. So these are going to be a little bit different than what we've done before. So when we look through these, our first case is going to be r is equal to 3 times the cosine of theta. Okay. So this one's a little bit different than what we did before. We just did like r equals, we did our polar coordinate points. We did r equals 2.5. That creates a circle, things like that. Now with cosine theta, it's going to get an interesting curve to it. In fact, like it's going to create kind of a circle, but it's going to look a little bit weird on my polar grid here. So we're going to go ahead and just make a chart with theta versus r instead of x and y. And I'm going to go ahead and plug in all my different thetas here into this equation. So what I'm going to get for this is going to be 3 times the cosine of 0, for example. So cosine of 0 is 1. So 1 times 3 is going to give me 3. Okay, so I'm going to keep doing that for all of these. I'm just going to plug in pi over 6 and pi over 4 and so on. So if I plug that in my calculator, I get some decimals. I'll get 2.6. Here I'll get 2.1, 1.5. This will come out to 0. This will be a negative 1.5, a negative 2.1, and then negative 2.6, and then a negative 3. Once we go beyond that, we're actually going to loop on itself again. So this is all I need in this case. So when theta is 0, we're going to go out to 3. So it's going to be this point right here. Pi over 6 is going to put me at 2.6. So I'm going to estimate that. So I'm going to go 1, 2.6 to be about right here. And then pi over 4 is going to be at 2.1. So it'll just be a little bit past there. Then we're going to get pi over 3 is going to be 1.5. About right there. Pi over 2 is going to give me a 0. So I'm actually going to go right here to this spot. And then 2 pi over 3. 2 pi over 3 goes to negative 1.5. So even though I'm going to this angle here, negative 1.5 is going to take me this direction. So it's going to go negative 1.5. So it'll be right down here. And as I go through, so negative 2.1 and 3 pi over 4, again, that's going to go opposite direction of this one. So it's going to put me at negative 2.1, will put me about here. I'm getting symmetry a little bit with the kind of like symmetry with my polar axis in a way. So then next one is negative 2.6 at 5 pi. So 5 pi over 6 again is going to put me over here. So 2.6 will be about right there. And then once I get to pi, it puts me at negative 3. So I'm back here to the first point. So I don't need to do any more points because it's just going to keep repeating itself. But I basically am creating a circle from this. Okay. So that is our basic setup. We're going to look at a couple more examples here. So we have r is equal to 3 times the sine of theta. So we're going to do the same exact thing that we did last time. So I've got my setups already. So if I go 0, 0, or I plug in sine of 0 is 0 times 3 is 0. So we're going to start right here at this point. And then we got pi over 6. If I plug these in, I'm going to get 1.5, 2.1, 2.6, 3, 2.6, 2.1, 1.5, and 0. Okay. So I'm going to go ahead and plot these points now. So I got pi over 6 is at 1.5. Okay. Sorry, what pi over 4 is 2.1. So 2.1, a little bit past that. Pi over 3 is 2.6. So 2.6, a little bit past the halfway mark. Pi over 2 is at 3. So 3 right here. And then we got 2 pi over 3 is at 2.6. 3 pi over 4 puts me at about 2.1. Then 5 pi over 6 puts me at 1 pi, or sorry, 1.5. So it'll be right about here. Okay. If I were to continue, if I went beyond that, I went to like, for example, 7 pi over 6. So if I made theta 7 pi over 6, my r, when I plug that in, would end up being negative 1.5. So when I look at that, negative 1 point, if I go to 7 pi over 6, I go to negative 1.5. I would actually go from here, here, I go 1.5. I'd be back mapped onto my original point. So I don't need to go at, like, I don't need to do any more thetas at this point because it's just going to map back on itself. So again, I get this circular shape right here when I connect them all. So that's going to be my polar curve from this. Okay. So when we have with our polar graphs, we have a variety of symmetries here. You saw what we did or before we did this one right here was the symmetry with respect to pi over 2. So that's going to be like its symmetry with this vertical line. The first one we did with our cosine created a symmetry with the respect to the polar axis, which is right here. Okay, so it's in respect to that polar axis there. Or we can have symmetry with respect to the pole. Okay, so that's going to be kind of like our odd symmetry from like previous lessons, but we're looking at a scenario where we have so like this point here, r theta maps onto like negative r theta here. So that's with respect to the pole at that point. So we're going to keep going with some more of these. So we got another complicated one. Here I'm putting it into degrees. I don't know why. I don't know why I did that with degrees. Probably should have just done this from 0 to 2 pi still. Well, it's fine. So just know that what we're doing here is still going to be within in terms of degrees versus radians. So just recognize where I'm at with that. So I probably should change that. You know what? I am going to go ahead and change that. So we don't need these. Let's go ahead and change that back to radians. It tells us to do it from 0 to 2 pi. So I don't know why I had it set up that way. Let's go. We'll have pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, and then 3 pi over 4, 3 pi over 4, 5 pi over 6, and then pi. But from there, we're going to keep going now because there's going to be something weird that happens with these. So I'm going to go ahead and go on to 7 pi over 6, 5 pi over 4, and then 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 11 pi over 6, and then finally 2 pi. That'll complete my interval here. So again, I'm going to plug this in the calculator. So I'm going to plug in 0. So for example, cosine of 0 is 1. 1 times 3 is 3. 1 minus 3 gives me a negative 2. So I'm just plugging in those values in all the cases. So pi over 6, when I plug that in, multiply that by 3, and then take 1 minus that. So we're going to fill in the rest of this chart. We should get negative 1.6 when we plug these in. We get a negative 1.1, negative 0.5 or 1/2, a positive 1 here for this one. Then I'll go to 2.5, 3.1, 3.6, 4, 4, 3.6 again. Then it'll be 3.1, 2.5, 2.5, 1 here, and then a negative 0.5, a negative 1.1, and a negative 1.6, and a negative 2. So now we can see that we're going to map on back onto itself. So so if it says it starts at 0, negative 2. So again, I would go to 0 here, but because it's a negative 2, I'm going to go the opposite direction. So here's my first point that I'm plotting. So then at 30 is going to be at negative 1.6. So it's actually, so instead of being here at pi over 6, it's going to go 1.6 about right here. So it's going to map onto 7 pi over 6. So the next one is going to be at negative 1.1. So it's going to be right here when I plot that point. Again, that's going opposite of the pi over 4, going the opposite direction of that one. Negative 0.5 is going to line up here with my pi over 3. So that's going to go right here. Negative 0.5. You're not going to see it here, but the next value is going to cross here. So if I did 5 pi over 12, it would cross at 0. We're going to go on to 9, or we're going to go to pi over 2, which is going to give me to 1. So that is going to go up here to 1 like this. Okay. And then now we're in our positive. So then the next one is 2 pi over 3 is going to go 2.5. So 2.5 is right here. 3 pi over 4 is at 3.1. So we got 1, 2, 3.1, a little bit past. Next one is going to be pi, puts me out here at 4. Sorry, I missed one. This is at 3.6. So it'll be about right here. So pi goes to 4, 7 pi over 6 goes to 3.6. So we got 1, 2, 3.6, a little bit further along there. 3.1 for the next one. So it'll be 3.1 is about right here. 2.5 at 4 pi over 3. So it'll be 1, 2.5. 3 pi over 2 goes to 1. And then I'm back at my negatives, but at 5 pi over 3 is going to be a negative 0.5. So that actually takes me to this direction right here. Negative, or 7 pi over 4 gives me a negative 1.1. So it's going to be about right here, negative 1.1. And then I'm going to get negative 1.6 on this line. And then I'm back to a negative 2. So I'm back right here again. So this one's a little bit trickier, but watch what the curve did. It kind of did this for its loop. It went this way here, took this long way around, and then it looped back on here to itself. So that's our shape here in this case. So a lot of things going on with that one. Just take it step by step. You're going to find how it goes through that way. Okay, for my next one, here's one that's going to have symmetry with the line of theta equals pi over 2. But also we have some context. So the area lit by two lights that shine down on stage can be represented by the equation R equals 1.5 plus 1.5 sine theta. Suppose the front of the stage faces due south. Graph the polar pattern of the two lights. So the two lights, so we're going to create symmetry on this line. We're already saying that here. It has to do with the fact that we're doing sine here instead of cosine. I'm just going to keep it in degrees. But if I plug these in, again, I'm going to plug them into right here for theta. And then I'm going to solve the problem through. So what I get is 1.5 here, 2.25, 2.6, 2.8, 3, 2.8, 2.6, 2.25, 1.5, 0.75, 0.4, 0.2, 0, 0.2, 0.4, 0.75, and then 1.5. So plotting those points, I got 0 goes to 1.5, about right here. 0 goes to 1.5, then pi over 6 goes to 2.5, 2.25, so about right here. Okay, then pi over 4 is going to go 2.6, so it's a little bit past. And then 2.8 right here. Pi over 2 is going to go to 3, so that's 1, 2, 3 right here. And then I'm going to repeat some of those numbers. So I got 2.6 is about right here. Or sorry, 2.8. Then it's about 2.6. 2.25 is right here. And then pi is going to give me at 1.5, so it's going to put me here. So you can already see how the path is going here. So far, the curve is doing something like this as we go along. Okay. 210 degrees is at 0.75. So that's going to put me at about right here. And then the next one is at 0.4. So I'm getting closer into the middle. And then I'm at 0.2. And then I'm at 0 right here for 270. Okay, so that curve is doing this. It's coming in and kind of bumping down. And then it's going to go to 0.2. So it'll be about 0.2 is right here. And then a 0.4, a little bit further away, a 0.75. And then I'm back here to 1.5. So then it does this. It kind of looks like an apple in a way. Okay, so there's my graph there. Again, just you're going to fill in a chart and take it step by step. So with that in mind, we're going to answer a follow-up question. If you look kind of the graph of that line, let's take a look. The area lit by two lights. Suppose the front of the stage faces due south. Describe what the polar pattern tells you about the two lights. So the lights will light up more of the back of the stage compared to the front. Okay. So what that means, so again, we're saying is if this is facing due south, okay, the stage, this is like the stage front. So this is the stage back here. So that is we're facing south for where the band's facing the crowd is the idea. Okay, so that means that the lights are lighting up the band here, but not as much at the front of the stage is what we're happening here. So that's kind of the goal with something like this. We want the band to be lit, but not the audience. Okay, and so that's it for our polar graphs to start for day one lesson. That's what we're going to leave you with here. Okay, so again, we're just going to create charts that compare theta to r. You're going to plug those into your calculator. There's ways to use it with our TI-84s where we can change into polar equations, which we can talk more about in class. But for now, just use it. You can just plug in step by step and make those tables like that. All right, that's it for today. Take care, everyone.